Why hello there, welcome back. This is part 13 of my build log of the Trumpeter 1:200 scale model of the Titanic. In today's episode I am covering the first test, which is not a cricket game. It's actually my first test of the boat in the water, although as you will see as we go on, it's actually my first and second test, because the first test was an absolute unmitigated disaster. So, without any further ado, I will crack on. One thing that I meant to show in the last episode, which I've done, is I've installed some mudguards over the joins between the universal couplings and the prop shafts. And the idea here is, you see, it's just a bent piece of acrylic, nothing particularly fancy at all, just a very simple piece of bent acrylic. But when these shafts spin round, it's difficult to get the camera focused, when these shafts spin round, oil can sort of spray out of them. And because they have quite a high RPM, oil can go absolutely everywhere. In some ships that's not an issue, but in this one, when I've got things like lights on the side and things like that, I really don't want the oil to spray everywhere. So these mudguards will just prevent oil from really messing up this area of the ship. Right, just back from the lake, from the first test. I'm just giving the hull a wee bit of a clean, because the lake wasn't the cleanest place in the world. So, how did it go? Well, it wasn't a complete disaster. On a scale from 1 to disaster, I would put it at about medium. So, yeah, it wasn't disastrously disastrous, but it didn't, well, I didn't get much actual sailing, let's put it that way. Essentially, it became apparent almost immediately that the propellers are not fit for purpose. So I think the issue really is that the props they're just designed to look like the Titanic's propellers, but they're not designed to actually push water when they rotate. So essentially I put the boat in the water and the props turned and it just snailed forward, hardly got any momentum at all. And of course that had the knock-on effect of making the rudder absolutely useless, because, the Titanic's rudder gets most of its turning power from having the central propeller directly in front of it. So if you don't have that, or at least if the central propeller isn't really propelling any water, that's not very helpful. And I'll show you here. See, normally all of your power in that rudder comes from the central propeller pushing loads of water directly behind it, but it just wasn't the case. And then equally, if you look at these props, they've not got a sharp enough pitch on them to actually push any water really. So I think that was the issue here. So what I'm going to have to do is I'm going to have to buy some proper model boat propellers with a decent pitch on them. So, a little bit disappointing, but this is exactly why you do tests, to find out where the issues are and to solve them. There were some positives from the test, however. I managed to sail through a patch of weed, which is, it can be a bit of a nightmare on model boats. It can gunk up your propellers, as you can see in this photo, and the real danger is it can cause your motors to stall. And when a DC motor stalls, that's when it pulls peak current. So there's a danger of blowing fuses and stuff like that. But because of the geared motors I had, the props didn't stall at all. The motors kept pushing through. So that's a genuine positive. There weren't any leaks, which was quite beneficial. The oiling system seemed to work quite well, and the range on the transmitter was perfectly adequate as well. So, there were some positives. Just testing one of my watertight compartments here. This is the bow compartment. As you can see, the water line is almost up to the portholes. So the water inside the ship is up to about this point here. which would probably make the ship about that deep in the water. So it's a depth which you are really going to notice if you're sailing the boat around a pond. There's enough water in here that you would really notice it from the bank. You'd know that something was wrong. You can see that the watertight bulkhead is holding this water back perfectly happily. This next compartment is totally dry, nothing's in there at all. There's about 3 pints of water in here, so there is a reasonable load on this bulkhead, but it's holding it just fine. So that's a really good and successful test. So we're a couple of days later now, and the new propellers have arrived. As you can see, the pitch on these is much steeper than the pitch on the Pontos propellers, so they will push a lot more water per revolution, which is exactly what I need. I am sacrificing a little bit in aesthetics. These propellers don't have the really nice bolted detail for the propeller blades that the Pontos propellers had, and you miss the sort of bulbous profile of the Titanic's propellers, but this is really a case where function has to come before form. When new, these propellers are a little bit too shiny for my liking, so I went and did the same process that I did with the Pontos props, and I pickled them in a mixture of malt vinegar and salt, just to take that shine off and to get them to oxidise a bit. I then attached the props back to the prop shafts with some Loctite, and I also made sure I used the locking nuts to properly secure those props in place. And then we're ready to go. At some point in the future I will paint the props in the areas they need anti-fouling paint, but that job is for another day. Right, I'm about to shoot off to the boating lake, and so before I do, I need to fill up my automatic oiling system. For the automatic oiling system, I am using a mixture of oil that I use quite a lot when I run my model steam engines on compressed air. I do quite a lot of stuff with model steam engines as well, and I find this oil is really good when you're operating at cold temperatures. I can't take credit for the recipe myself. This is a recipe that I got from another YouTuber called Keith Appleton. I'll put a link down to his channel, but he does a fantastic selection of videos on model steam engine repairs and masses more besides. He's well worth checking out if you're interested in that kind of thing. The recipe of oil he uses is 50% live steam oil, 25% machine oil, and 25% vegetable oil or rapeseed oil. And that's what I'm using as well. It seems to do a really good job of lubricating small mechanical systems even at low temperatures. You wouldn't really get away with using something like live steam oil because that is designed to lubricate under pressure and steam, i.e. when the steam engine is running on actual steam, not compressed air. And having the other two oils in that mixture kind of balances it out and allows the mixture to lubricate at low temperatures. So I charged up the batteries, packed the boat in the car, and went off to the boating lake. And what follows is what happened. And so there you are, the first test. Titanic made 307 for the loss of 3 wickets in 108 overs, and to be honest, did pretty well. I've got to say, one thing that always strikes me when I sail a boat for the first time is it's amazing how a ship that takes up masses of room in your house very, very quickly starts to feel very small on a boating lake. Even when you sail it sort of, 10, 15 metres away, it feels so small. It's really quite unnerving, actually. Anyway, on to the actual performance. She accelerates pretty well, which shows that the new propellers have really done their job, and she decelerates reasonably well. Steering is actually not bad at full speed. It's pretty disastrous at low speed, but you would expect that because steering's obviously proportional to the flow of water over your rudder. The other thing to bear in mind, I suppose, is that there is about 1.5 centimetres of the rudder out of the water. So when the ship is fully loaded, she is going to have a much better turning capacity. So that's probably worth bearing in mind. And to be honest, it sounds a bit perverse, but I quite like the fact that she's not the easiest boat in the world to sail. Bear in mind, this is a 1912 ocean liner. There's no such thing as bow thrusters. There's no manoeuvrable propellers so that you can power in different directions. I like the idea that there's a bit of skill involved in manoeuvring the ship, because it keeps it interesting, So I was actually pretty happy with how the ship performed today. So I'm back now from the lake after my first successful test run. Second actual run, but the first one was, as I've already shown, a bit of a disaster. So we're back after the first successful run. And so I want to show you one of the features that I'm particularly pleased with that I've added into this boat. It will become a lot more clear as I start to add the superstructure onto the ship. But one of the things that I was very conscious of from the start is that disassembly of this boat will be tricky at the best of times, because for anyone who has the kit, you'll know that the detail on the model above the hull is exceptionally good, but what comes with that is that it's exceptionally fragile as well. So unnecessary disassembly is something I really want to avoid. And needing to take batteries out to charge after each run is quite problematic, particularly when you've got one battery buried right underneath all your electronics, another one wedged between a superglued bulkhead section, and a third right in the bow underneath the forecastle and well decks, which ideally don't come out of the ship. So what I've done is I've come up with a method of charging the batteries in situ, and this is, well, it's pretty straightforward really. It's one wire here which goes into your positive main terminal, and a second here in your negative main terminal. And I can connect in my battery charger directly into these, and I can charge all 3 batteries in parallel. It's important to make sure that your charger is up to the job. It's quite easy to overload this if you're not careful, so you've got to make sure that this is capable of charging 3 batteries in parallel at once. Mine is, so happy days. But what this means is that I can charge these batteries without ever needing to disassemble the boat. So the only time I'm going to have to take decks up and disassemble this is if I need to do serious maintenance. If I need to, let's say, replace a motor or do something genuinely invasive. But for everyday repurposing of the boat after a sailing, I don't need to bother. So the other thing I'm going to do is I'm just going to check the voltage level on my batteries now, because that will give me some sort of indication of how much power I actually used. It's not measuring voltage and using that as a means of working out how much battery power you used is not particularly scientific, and it varies depending on the history of the battery and yada yada yada, but it gives you a rough idea of how much you use. So at the minute my batteries are at 12.61 volts. Normally when fully charged they sit at around 12.75, so they have gone down a wee bit, but not a huge amount. But like I say, that's not particularly that doesn't particularly give me any real idea of how much power I actually used. But as I've said in previous videos, it's really important to make sure that batteries especially lead-acid batteries, are charged up as soon as possible after you have finished your test run. So that's what I'm doing now. My charger is plugged in and the battery charging is underway. And I tend to leave this overnight, really. And if we check the voltage now, you can see that it actually, you can see that batteries are accepting current because the voltage has gone up across them. So we'll leave that for a wee bit and see how it goes. So I got back from the boating lake last night and I put my boat on charge and she's now finished charging and I've just put her back into where I store her. And this is my oil drip tray, which is actually one of my plates. Not a great use of a plate, but there you are. And I'm really happy to see this in the oil, this sort of dark spludge there. So that's your normal colour of oil. And there's a dark splodge and there's another one there. Good scientific word, splodge. Now what this shows is that the bearings in the prop shafts are running in properly. So when you first get a bearing, or any metal surface which is going to take as a moving part, it's going to have high and low points. And as the shafts spin for the first time, those high points get sort of almost sanded away. And you end up with bearings that become much smoother and more polished than they were at the start. And this process is called running in. It's perfectly normal. You do it with steam engines and anything else besides, any moving part really. And you'll find that after the running in process, your machine will run a lot smoother than it did to start with. And the upshot of this is that your oil, as it drips out, is going to have particulates of metal in it, which makes it much darker. And that shows you that the running in process is happening. After a while, you expect the running in process to complete, and at that point, I would expect all of the drips coming out of these prop shafts to all be this just normal oily colour of brown. And that'll show me that the boat's properly run in and ready to be used more intensively. So I'm really happy with that. That shows that we're going in the right direction. So to summarise, I'm pretty happy with where I am at this point. From looking at discharge curves of these batteries, along with voltage measurements I took, I reckon that I used about 40% battery capacity. And I was at the lake for 2 hours, and I think really 40% battery capacity over 2 hours of running is pretty good, to be honest. It's worth bearing in mind that the finished boat is going to have a bit more power usage than that, because I'll be running the lights more than I did today, and I'll also have the smoke systems on, so they will eat up a bit more battery power. But even so, I think that's a pretty good endurance, really. And there are other positives to take from it as well. The boat's unbelievably stable in the water, and that's really due to the amount of weight that there is below the waterline. But she virtually never came off an even keel. Even turning at full speed, she didn't come off an even keel. In fact, the only time she did was when there was relatively strong gusts of wind blowing across the entirety of the length of her hull. So that's really positive, and that gives me a bit of confidence that when I add the superstructure, she's going to remain stable. And other things, I didn't blow any fuses, which, you know, I shouldn't have done, but is always reassuring to know that you're not going to. I didn't lose any connectivity with the radio throughout the sail, so it was a really good, solid first test of the boat. So that's it for this episode. I'm going to leave it there. In the next episode, hopefully I'll get on to actually doing some of the superstructure work. But that's it for now. So if you've enjoyed it, please give me a like and even think about subscribing. If you do have any questions or comments, leave them down below and I'll do my absolute best to get back to you. And I will see you in the next one. Bye for now.